Hey there, welcome back to Farmcraft. I'm John. And she still doesn't track straight. So I did a previous video on this excavator with its tracking issue, and I've got a lot of good information from a lot of people out there that know a lot about these machines, so thank you all for that. And you're really going to want to watch that video first if you haven't seen it yet, or this video is not going to make a whole lot of sense. Basically, when I bought this excavator, it always tracked to the left, and I've done a whole lot of testing to try to get that figured out. And in this video, I'm going to kind of settle it once and for all, and I'm going to give some recommendations on what I've learned in this experience, what I think you should do if your excavator's not tracking straight. And hopefully that'll help somebody out there. This is a really common issue, and it's a big deal for some people and not so big for others. When you tow your equipment to a job site and you go up to a house foundation and you're doing your digging and then you're back on a trailer, it's not that big of a deal because you're not tracking distances. When you're on a farm and you're going to a job site here and another one that's 1,000 yards over that way and another one that's 2,000 yards that way, well, it seems like you ought to at least be able to track a little bit. But when you start tracking any distance, not going straight is a big hindrance. So you end up loading it on a trailer all the time anyway. It just seems like a waste of time. It'd be nice if the machine would go straight. So let me start out by reviewing everything that we've done to this point, and then we're going to pick it up and we're going to do a couple more tests and come to a final conclusion on this, because I do need to load this thing on a trailer and take it over to a job that we're going to be doing hopefully in the next video.
So the first thing I did was, using some extensions, I swapped the lines at the travel motors. So the oil that would have gone to the left motor is now going to the right, and vice versa. So if the problem changes sides, that's because the oil being fed to the motor is the problem, not the motor itself. So I was thinking it was going to be a travel motor, so I did not expect it to change sides, but sure enough, the excavator started tracking to the right, where before it had been going to the left. This also eliminates anything else on the undercarriage. It's not a stiff idler wheel with a bad bearing. It's not a problem with a track or anything like that, because it switched sides. Now it's doing it on the other side with the other idler wheel and the other track. So it's coming from above. I then put gauges on the outputs of the control valves, trying to test for internal leakage. But unfortunately, there was no way for me to really tell with this testing method. So I took out both control valve spools and inspected them. I found that they were basically exactly the same, to within 1/1000th of an inch, probably to within 1/10,000th of an inch. They really looked very good. So then I swapped the hoses between the control valves and the swivel joint, just to verify that the swivel joint was okay, and I found that the swivel joint is functioning fine. The problem's coming from above. So I finally got around to swapping the lines at the pump. I wish I had done this a lot sooner, because when I swapped them at the pump, the problem changed sides, and that shows that the pump is the major issue here. One output of the pump is putting out more fluid than the other, and that track is going faster. So then I decided to couple the pump outputs together. That would eliminate any differences between the two outputs and see if that would go straight. I was convinced that it would. I knew it would cause other problems with the machine, but the machine actually went left. So my conclusion was that I had problems in multiple areas simultaneously, and I was thinking I was just going to have to live with it. But there were some other things that I needed to check and think about, and that's where we're picking up in this video.
So many of you suggested that I swap the spools in the control valves, and that's actually a pretty cool idea. I like the idea, but I took those spools out and I mic'd them. I mean, they were exactly the same to the 1,000th of an inch. So yeah, I could swap them, but I think it's a waste of time at this point. The control valves clearly are not the primary issue here, and if there is an issue in one of the valves, it's most likely the valve body. It's not going to be in the spool.
That's typically the case because the valve body is cast iron and the spool is hardened steel, so it's the body that's going to wear. So one more trick I want to try. I'm going to couple the lines together right at the travel motors. Both motors will be getting exactly the same flow of oil and pressure. If the motors are the same, then they should drive the same, right? I've got my vacuum running, but I think it didn't have a good seal. This side went a little better. Vacuum had a good seal.
I am tied together now, and I have equal pressure and flow to both motors in that direction. So if this doesn't track straight, the only differences can be in the motors. So let's see what that does.
Just note that I only have the lines coupled together in one direction of the motor. The other direction I would still expect it to deviate to the side. And I think you can see in this direction it's going to the left. Hey, look at that. I think that was going straight. Let's get all the way out here. That is tracking straight. How about that?
You may or may not have noticed there, I was able to turn in one direction. In other words, when I was heading that way, I still had control over my direction. Because those lines are hooked together, now my control valves send oil equally to both motors. So putting one stick forward drives both motors. So I did not have the ability to turn in the opposite direction. So it's not like, you know, you can hook it up like this and you're going to go straight. You would need to have some valve that you're able to control. You could do, I guess, just in one direction. That would be an option. But because of the swivel, it would have to be done above the swivel. There's no electrical swivel on here, so I don't have a way of getting an electrical, unless they make like a wireless hydraulic control valve that has batteries and radio frequency. It is not worth all that. Could it be straightened out? Yes, it's possible, and this proves it, which is really what I wanted to do this for. The drive motors are equal. It's definitely not those. Hey, I want to thank the sponsor of today's video, Vevor. They're adding a new tool to my kit that's kind of long overdue, to be honest. That little guy is a 210 amp TIG welder, and it's also a stick welder. You know, Vevor is a budget tool company, but they make pretty solid tools that do what they say they're going to do.
Like their Cut 50P plasma cutter. Here I'm cutting a piece of 1/2 inch AR 400 plate. Cuts right through it. They've been selling so many of these, they're having trouble keeping them in stock, but they tell me they have a good stock right now.
I've been impressed with them in the past, so they wanted me to check this out. I said, sure, send it on. And I got to say, I'm pretty impressed with it. Now, I am new to TIG welding, so I had a friend of mine who's a professional welder check it out, and he was actually impressed with it. And he TIG welds on a daily basis, so I think for the money, this is going to be hard to beat. Now, this is a DC TIG welder. You have to have AC in order to weld aluminum, but it will weld all the other stuff you expect from TIG. You can weld stainless and copper, and of course your mild steel and carbon steel, all that kind of stuff. Now, this is not an example of an expert TIG welder. Let's acknowledge that. But I'm going to do a little TIG welding, and we'll see what this thing can do. You know, this thing's really nice. It's got a nice little trigger on it. Seems like a really good entry level welder for someone like me that needs to figure this out. Let's try something a little bigger, and let's see if we can't make a weld here. So yeah, I think I had my arc too long there, but hey, that's a TIG weld, and I don't think that's going anywhere. So this is a piece of stainless steel. Let's just butt weld them. Definitely had too many amps for that. Hey, that looks like a weld. Welding stainless, that's pretty darn cool.
I got the stick welder hooked up and gave that a test too.
So clearly I could use a lesson in stick welding too, but man, I'm really glad to have this. What a versatile machine. So if you're interested in getting into TIG welding like I am, or you need a stick welder like I do, this is a really good deal and a good machine to start with. For some reason, they actually don't give you the lead for stick welding. So what you need is a DINS type connector. This one is, it says DKJ 1025, and this right here is your stick welding connection. It just plugs in right there. So, and then of course they give you the ground clamp, which you put on positive for TIG, and your TIG torch. Everything's included there. It's got a flex head. It's a pretty nice torch. Nice trigger on it. Easy to use. If you're interested in one, check the links in the description.
And just like their plasma cutter, these are selling like hotcakes. So if you want one, order soon.
But for right now, let's get back to work. Yeah, I still think my problem is coming from the hydraulic pump. Yeah, this guy right here. And people tell me it's not too bad to rebuild them. One day I may do it, but it's not worth redoing a rebuild just over this issue. This just isn't that big of a problem to me. Now, the other thing is this accumulator. Several people suggested that I eliminate that. I think it's very unlikely that that's the problem. Basically, it's a wide open port from here to here. So it's an elbow, just like that is. And it just has this to act as a buffer. I didn't have the fittings to be able to actually eliminate this accumulator until recently. So I am going to go ahead and eliminate it and see if that makes any difference. First, though, I need to put this back. Many people did comment that accumulators like this can do some really goofy things and make unexpected things happen in your system, and apparently they do wear out. See what happens when we remove the accumulator. I think nothing, but let's verify. Now, a couple people thought that this was an adjustment, that it was pushing on a spring behind there. That's not the case. That's just a port, just like that is a port for checking the pressure on that side of the pump. That's basically a plug, is all that is, nothing more. It's a little contrived, but this is a tapered pipe thread. I can't just use my T and go into that because that's a non-tapered British pipe. It would leak like crazy. So that comes to non-tapered British pipe, but then it's male, so I had to do this coupling to go to the male of the T, cap the other end of the T off, essentially converting the T into an elbow. So it's just a straight shot here to an elbow, just like this to an elbow. The accumulator is eliminated. Let's test it. Let's see if it made any difference. So the way this thing is set up now, it would go to the left because the machine's actually facing backwards. I don't think the accumulator is going to have done anything, so I would expect it to still go left, but let's see. All right, as I expected, no difference there. So I put that back. This is how I'm going to run the machine for a while. I've got some things to think about. So I have determined my travel motors are equal. And if I want this thing to travel straight, all I have to do is couple them together. The problem is that you can't turn when they're coupled together. So you have to have control in the cab of whether they're coupled together or not, which means installing control valve, controls, either manual or electric, something like that. Now, you might think it wouldn't be that hard. I could just, put a T somewhere on that line and a T somewhere on this line and hook them together right here in the undercarriage. The problem with that is there's no way to control it. You have to use the swivel joint because there is no electric on the lower end of this machine, no electric in the undercarriage. If you had a way to send a wire down that wouldn't get tangled up when you rotate the house, then yeah, that would be fine. But I don't have any way to do that, and I'm not going to install an electrical swivel. That would be a bear. So I need to use the existing swivel joint, which means I have to couple them above the swivel joint if I'm going to do that. And that means I'm in here. You can see there, I don't have a ton of room to work with, but there are options. It's these two lines are the travel lines. These are after the control valves, before the swivel joint. So I need to couple those together and be able to control it. I need a T and then a control valve that is probably going to be an electric control valve, though a manual one is an option. If I could put T's here and then get up underneath here, there is some room over there. I'd obviously have to take this panel off, and then maybe I could put like a foot pedal or something up through the floor that would actuate it. That would be kind of cool, actually. If I hold the foot pedal, it goes straight, and if I let off, I'm able to turn. I have to decide if I want to do all that, because I'm going to need a whole bunch of hoses, a whole bunch of fittings, the valve, and I'm just not sure it's worth it at this point. And I know I don't have time right now because I've got a job coming up, and a schedule, so I've got to get this thing back in action. And speaking of that, I have a couple more things I need to do. One, I'm going to change the hydraulic oil, but actually I'm going to filter the oil that's in there and then put it back in and top it off. I want to show that to you guys. And the other thing is, I keep losing bucket teeth. This one is a new tooth, and that one has stayed put okay. But yeah, these, see that? The keepers are coming out. And I was able to find the tooth that fell off, and then I was sitting there looking for the keeper. Well, the keeper's still in there. Like, what the heck? So I'm going to put some new bucket teeth on this thing, and I'm going to use the welder so I don't have to worry about them falling off. So we're going to take care of those. But first, let me do a summary of what I've learned on the travel motors and my recommendations. Now, this is based on my machine. I think most machines are set up very similar to this, even if they're bigger. But, you know, some brands you might have a different setup. But let me try to break it down simply and logically so that you have a kind of a stepwise idea of what to do if you want to try to troubleshoot your excavator not tracking straight. All right, so excavator travel in a nutshell. I must say I was really surprised. I got so many comments from people that are experienced with excavators that told me just don't expect an excavator to travel straight. Even brand new ones oftentimes will pull to the side. Many people said any machine with over 1,000 hours on it, it's just not going to travel straight. The machines just aren't designed to. And now that I stop and think about it, it really kind of makes sense that they really aren't designed to. You've got two different pumps basically. Again, really this is one pump with two isolated outputs, but it acts like two pumps. But these two pumps separate here, and everything else beyond this is totally separate. So how are the two drives going to be perfectly in sync with all the little variations you have? You might have slight difference in length of hoses. You might have differences in your control valves, difference in your swivel joint, difference in your travel motors. They're just not going to track straight. So my end conclusion with my machine is there's nothing wrong with it. It's just a machine with 3,000 hours on it, and this is what they do. It works fine otherwise. Most excavators, you don't need to travel long distances. But depending on your use case, when you live in a place like I do, and I want to go do some excavation over that rise over there, that takes a long time to get over there, and it's pretty annoying when it doesn't travel straight. So that brings in the question, do I want to do some modifications to the design of the machine, adding another control valve to force it to travel straight? And I've determined how to do that. That will work as long as your swivel joint is okay and your travel motors are okay.
Let me add that many people suggested that I put a flow restrictor on the fast side, basically slow down the fast side so that it goes the same speed as the slow side. That's a cool idea, and I appreciate all the ideas, but that really won't work for me, and I explain why at the end of the video.
So, if your excavator doesn't travel straight, my advice would be, first of all, you have to decide how bad is the problem. If it's not that bad, just live with it. But if it's really driving you crazy and you really want to fix it, then this is where I would start. I would start at the pump, because flipping those two lines is not going to require any fittings. It's going to take you a few minutes, and you can flip the lines. Now, if you flip those lines and the problem flips sides, then the pump is the major issue with your system. And you have to decide, do I want to do a pump rebuild, which is going to be a pretty pricey, involved thing. If the machine's operating okay otherwise, you're probably not going to want to do that, and you can stop there. If it doesn't flip sides, I think, you know, the next two things you'd think about are the swivel joint and the travel motors. Probably the easiest thing to do would be to swap lines, go into the travel motors to see if it flips sides. So if you swap the oil, go into each motor into opposite sides, and the problem stays on the same side, then it's the motor. Now, keep in mind there are other possibilities. You could have like maybe a bad idler wheel that's not allowing it to spin on one side, but basically it's your undercarriage on that side, if it stays on that side. You've now isolated it to the undercarriage, most likely the travel motor. And there are other testing things that you can do on travel motors like K-strain and stuff. I didn't do that because my travel motors aren't the problem. When I flipped those lines, the problem flipped with it, which tells you it's not the travel motor, it's not the undercarriage. And that's definite. There was a lot of questions about that. If it flips sides, you don't have to check your idler wheels, you don't have to check all that, because this one was going slow, and now this one's going slow. Clearly there's nothing wrong on either undercarriage because it wouldn't flip sides like that. If the major problem was a tight idler wheel, it's going to be the tight idler wheel on this side. That's the problem. It's not going to be flipping back and forth. I hope that makes sense. So I would flip at the pump, then I would flip at the travel motors, and then I would check your swivel joint. And the easiest way to do that is going to be to flip the lines between the control valve and the swivel. And it's kind of the same process of elimination. So if you flip the lines between the control valves and the swivel joint and the problem changes sides, then it's not the swivel. If it doesn't change sides, then it's the swivel joint, assuming you've already checked your travel motors. This does get kind of confusing to think about, but whenever you swap lines, if the problem changes sides, then it's coming from above where you swap the lines. If it doesn't, then it's coming from below where you swap the lines. Now, the control valve is a possibility. Again, it's going to have to be pretty bad for you to want to tear into all that. That's going to be expensive, time-consuming, and in most cases, this isn't really considered a problem. This is just the way excavators are. You're going to have to decide if you want to do anything to fix that. And I still haven't decided on mine. I'm going to live with this for a little while. I'm going to use my trailer if I have to move any significant distance and decide if I want to go tear into that. But you guys, leave a comment if you want to see me do that repair. If I know there's a lot of interest in it, you know, would make sense if I could make a video. And yeah, it might be kind of fun. I'll think on it. Maybe we'll do that repair in the future. But I got other stuff to do with the machine right now, so we're going to go on to other things. Let's get this bucket fixed up first. Now this is an older style bucket. I think most of the newer buckets, the keeper comes in sideways. Now last time I put a tooth on, someone saw this and thought it was plastic. It's metal. I don't know why they paint them green. It's not going to stay green for long.
This piece of hard rubber interacts with the metal keeper and kind of keeps it under tension so that it's supposed to keep it from falling out. Not always successful though.
All right, now I'm just going to weld around these pins just a little bit, get them as balanced as I can. I'm not really trying to weld it to the tooth, I'm just trying to make the pin wider out here so that it can't back out. And yeah, hopefully that will stay put a little better.
I would have used the new TIG welder for this, but I didn't have my argon bottle yet.
Like lots of things that I do, it's not pretty, but that's not going anywhere. Okay, this may be a work in progress, but here's the deal. I've got some very clean buckets, and I am going to drain the oil into those, and then I'm actually going to transfer it to a 1 gallon container down there through this funnel. And then I bought this on Zorro. It was like $20. It's a 3 micron hydraulic filter with the filter housing. And then this was like 25 bucks, I think, for some hose that would go into it. Now what I don't have is a good funnel So I use some of my plumbing fittings up there. It's definitely a rig. But I just want to see if it works. Is that enough gravity and enough pressure to get a decent flow rate through there? Because then I can filter this oil straight into another very clean bucket to 3 microns and put it back in the machine and feel very good about that. And if this isn't too much of a pain, I mean, this thing holds like 10 gallons of oil, so it's going to be 10 trips with the bottle. It all depends on the flow rate. Now, obviously, I may end up having to buy a pump to do this effectively and efficiently, but this isn't something I see I'm doing very often. You know, this will be here and there, but it will be nice to be able to filter my hydraulic oil whenever I have something go wrong, just as a precaution. You know, hydraulic oil is so important. It's more important in my view than most engine oils, depending on the engine, because, you know, the engine oil's got to lube the engine. But this hydraulic oil has 2 travel motors, every hydraulic cylinder on this machine, the swivel motor, and the control valves. Everything needs to be lubed, and it can't be contaminated, and if it is, you're going to damage all of it. So, like, you know, you can buy a new engine for $5 grand. You can't buy all the parts on this thing for anywhere close to that. So anyway, that's why I'm being so anal with this and seeing if this will work. As a one-time use, this would be a waste of time. Just buy new oil and throw out the old stuff. But this might be something that I'll do in the future. So let's see how it goes. It's impossible. I guess if I had a pump that could pump from one bucket to another, that'd be the way to go.
I'm transferring to a 1-gallon container because trying to pour a 5-gallon bucket at the top of that ladder into a little opening is not going to go well.
So is a gravity pump a reasonable idea? Probably not. I actually think it's working. I mean, if I can just come up here and dump the whole gallon in, that's not bad. Oh yeah, look at how fast that's flowing. Huh. No pump required, just a little gravity.
So I must say I was surprised how well this worked. It turned out I could do a gallon about every 4 minutes.
I got all that oil filtered, so let's get this tank filled back up. You know, I don't know if I've reminded you in this video, the reason I'm doing this is because I had that gear pump go bad recently, and it had little bits of metal and stuff in it. Now, metal that I can see, I'm sure was caught by the filter that was in here, but trying to take care of this thing as best as I can, I'd rather not have to keep doing repairs on it. All right, so now we have 3 micron filtered oil in the hydraulic tank, which is great. It's actually still a little bit low, but it's enough to run it on. The issue is all of these hoses, the pump, the swivel motor, the travel motors, all the hoses and control valves under there, all the hydraulic cylinders and all the hoses out here are all full of unfiltered oil. And I believe there's like 5 gallons of oil in the system. So I just put about 8 gallons in the tank. I think it's supposed to be 10 and will be when I'm all said and done here. What I'm getting at is I am going to start this thing up and I'm going to cycle every function, including the travel. I'm going to circulate all the oil through, and then I'm going to drain the tank again and we're going to filter it again.
So I'm also going to put a new hydraulic filter in it now. This is the return filter. I believe it's 10 microns. So we're going to run that through the filter one more time up there, or down there. And that's a 3 micron filter, so that's better than is what's coming out of the machine. And then we'll put it all back in, and then I'm going to top it off with some brand new oil. And then we're almost ready.
So yeah, like I said, if this was a one-time thing, this wouldn't have made a lot of sense, because I spent like probably 60 bucks on the hose and the filter and everything to save 100. And with my time, that was not worth it. But now I've got the stuff for next time, and that filter obviously has plenty of life left in it. And there will be a next time. Something will break, and you know, if I'm replacing especially a motor or something on a machine, it'd be nice to be able to take that oil down to a 3 microns and put it back in if it's new. That'll do it. Figure out what I'm doing yet? Yeah, one more thing to do, and then with the exception of possibly modifying it to make it track straight, I have nothing else to do this excavator right now. That is, I want to change this final drive oil again. You recall in my first video on this machine, the oil looked horrible. Pretty dark. I think it's been a while since that was changed. Same nasty smelling black stuff. I don't know. I think this smells burnt. And I've run it for a while now, so I'm ready to change it again and hopefully get all that junk out of there and kind of have a fresh start. So let's get that done. Definitely not as bad as it was before, but still black and sludgy. That's why we're doing this. Yeah, see, it's dark, but it's not jet black all the way through. Before, it was like tar. Sorry, did I get you? Yep. So you want to see the other side? Hope not, because I didn't record it. I did the exact same thing. This confused me at first. If you're wondering, what's the difference between a travel motor and a final drive? This is the final drive. Behind here is a planetary gearbox that gears down the output to then give a low high torque RPM to the sprocket. So the final drive is the gearbox. This is the travel motor. That's a hydraulically driven motor that spins the final drive. The dozer over here does not have a travel motor. It just has the engine, which goes back through the transmission, drive shaft into the bevel gear, and then into steering clutches, and then into the final drive, which is another gearbox that then drives that sprocket, gearing it down, making it very high torque. So travel motor is a hydraulic motor, and a final drive is the gearbox that basically drives the tracks. All right, guys, I just greased the boom and all the pivots and everything, and this baby's ready for action. Now, the travel, I still haven't decided. I am surprised to find that the answer is excavators aren't intended to travel straight. You just have to deal with that. Yes, when I'm in low, I can just hold the sticks at different angles and I can force it to go straight. But then when I go into high, it has a differing amount of change. And actually in high, it just doesn't really work if I do that. So pretty much in high, I have to have both all the way forward, and then in low, I redirect. So yeah, I can fight with it and I can make it travel reasonably well. I just really would have thought there'd be a way to make it go straight. Well, there is, but it's a modification. The machine is not designed that way. So, but my point in all that is that putting a flow restrictor on the fast side is really not a good option. There are times when I'm going to want to go right and I'm going to want to go full speed. So like, why slow yourself down? That doesn't really help me. Yeah, let me know if you'd like to see me do the modification in the future. Maybe I will do that. But for now, I've got a job to go to. So let's get this thing loaded up. Thanks for watching. We'll see you on the next one. Wow.